Okay, welcome to the deep dive. This is where we take that stack of sources you give us and really try and pull out the essential stuff, the knowledge you actually need. And today, well, we're heading way, way out there to the very edge of our known solar system. We're tackling a name, Planet X. And wow, it's a loaded term, isn't it? It's got huge scientific ambition behind it, but also, let's be real, a massive amount of conspiracy theory baggage.
Oh, absolutely. It's such a fascinating topic, partly because the name Planet X is so, well, complicated. It has this split legacy. So our mission today, really, in this deep dive is to completely dissect this. We need to clarify which conversation we're even having when someone mentions that name.
Yeah, we have to nail down that difference right away because, for a serious astronomer, Planet X is really just a placeholder. It stands for the scientific idea, a possible big planet way out past Neptune, the one researchers are now properly calling Planet 9.
Right. But then there's the other meaning, the one that's kind of permeated culture. That's the mysterious hidden world,
Yeah.
often tied to, like, doomsday scenarios, Nibiru.
So it's this catch-all term. Means cutting-edge astrophysics to one group.
And total myth, end-of-the-world stuff to another. And honestly,
Yeah.
they share basically nothing but that generic name.
Okay. So we're going to explore the actual compelling gravitational evidence for the science version, why astronomers think something has to be out there. And then, yeah, we're going to lay out the detailed evidence-based reasons why the mythical version just doesn't hold water at all.
It's a journey out to where the map kind of ends, where the known stuff stops and the theoretical or the purely fictional begins.
Okay, let's do it. Let's unpack this. Where do we start? Defining the frontier.
Yeah, let's orient ourselves. To even think about finding Planet 9, you first have to go way beyond the planets we know well, past the gas giants. This whole idea lives in the really distant solar system, specifically the region that kicks off right after Neptune, the Kuiper Belt.
The Kuiper Belt.
Right.
That's not just empty space, is it? It's this huge ring of icy bodies. Goes out for hundreds of astronomical units AU from the sun. Full of things like centaurs, Plutinos, basically leftovers from when the solar system formed, like a deep freeze archive.
Exactly. And it's got some major players anchoring it. Pluto, obviously, is the biggest known trans-Neptunian object, a TNO. But we also have other big dwarf planets out there like Eris, which is actually more massive than Pluto, and Sedna. Sedna is really interesting.
Sedna. Yeah, tell us about Sedna. Why is it so important here?
Well, Sedna's orbit is just incredibly long and really stretched out, very eccentric. It goes about twice as far from the sun as Pluto does at its farthest point.
Twice as far as Pluto? How long does it take to go around the sun then?
Get this, about 11,400 Earth years for just one trip.
11,000 years. Wow. That's longer than all of recorded human history, basically.
Pretty much. And that just highlights how incredibly vast that region is, hundreds of AU wide. There's just so much room out there for something really big to be hiding undetected.
And that immensity, that's where the modern scientific idea of Planet X, Planet 9 really comes from, right?
Exactly. It's a hypothetical, yeah. But it wasn't just dreamed up. It was proposed specifically because of how some of these really distant TNOs are behaving. Their orbits are peculiar organized.
Okay, let's get into that. The technical details. It wasn't just a hunch. It was specific observed anomalies. What were they seeing?
The key thing is the weird clustering of the orbits for a small group of the most extreme TNOs, the ones with these enormous Sedna-like orbits. See, if their orbits were just random, they should be pointing every which way, scattered all over the place relative to the plane of the solar system. But they're not.
They're structured instead.
Highly structured. Their orbits are super elliptical, right? Stretching way out. But they all share these three really odd characteristics. First, they're all kind of pointing in the same direction in space.
Yeah.
The point where they get closest to the sun, the perihelion clusters in the same quadrant of the sky for all of them.
Okay, that's weird on its own. But you mentioned tilt, too.
Yep, the inclination. They're all tilted strangely compared to the main flat plane of the solar system, the ecliptic, where the main planets orbit. But here's the kicker, the bit that really makes physicists sit up and take notice. It's called anti-alignment.
Anti-alignment. Okay, what does that mean?
So if you look at maybe the 6 or so most extreme TNOs, the ones that really form the basis of this hypothesis, their orbits aren't just pointing the same way. They show what's called apsidal anti-alignment. So their closest points, perihelia, are clustered together. But the direction of their farthest points, their ephelia, points roughly opposite to the aphelia of some other important TNO populations. This pattern, this kind of structured opposition, It just shouldn't happen randomly.
Mm.
The odds of this specific clustering occurring just by chance, it's estimated at less than 1%, maybe even 0.1%.
Wow. Okay. So it's like seeing footprints in the sand, but you can't see who made them.
Mhm.
We're seeing the effect of something massive, something we can't see directly, but its gravity is basically hurting these tiny TNOs.
That's the core idea. You need a significant gravitational influence way out there, like a big anchor, to shepherd these little icy bodies into that specific, non-random clustered arrangement. That anchor, theoretically, is Planet 9.
It's fascinating stuff. But this whole search for a Planet X, it's not actually new, is it? It feels like I've heard this before, from way back.
You're absolutely right. The hunt for Planet X actually has two completely distinct eras in history. They're separated by about 80 years, and crucially, by a totally different understanding of astronomy and different evidence.
Right, this is where it gets really interesting, because the first search for a Planet X wasn't looking way out in the Kuiper Belt at all, was it?
Not at all. The original idea came about in the early 20th century. The main proponent was the American astronomer Percival Lowell. He theorized a large planet had to exist, but his reasoning was based on trying to explain these tiny, unexplained wobbles or discrepancies he thought he saw in the orbits of the ice giants, Uranus and Neptune, much closer in.
Ah, okay. So the original problem was basic Newtonian physics, right? If Uranus and Neptune weren't quite where the math predicted, something big must be pulling on them gravitationally. They were looking for a massive culprit perturbing the known planets.
Exactly. And this led to a huge, very dedicated search effort, especially at Lowell's own observatory in Arizona. And that hunt, the search for that Planet X, is what led Clyde Tombaugh to famously discover Pluto back in 1930.
Right, but Pluto turned out to be, well, tiny, way too small to be causing any noticeable wobble in giants like Uranus or Neptune.
Precisely. Once they figured out Pluto's mass, it was clear it couldn't be Lowell's Planet X. Eventually, astronomers realized those supposed wobbles in Uranus and Neptune's orbits weren't real either. They were mostly down to slight miscalculations of the masses of Uranus and Neptune themselves, and just tiny errors in the early observations. So the whole basis for that original search kind of evaporated.
So that first Planet X idea, the one messing with Neptune and Uranus, was scientifically disproven, done and dusted.
Pretty much abandoned, yeah. But science moves on, and the name Planet X got this unexpected revival like 80 years later in the mid-2010s. But this time, it was focused on totally new evidence, way, way further out in the solar system.
And this is where Konstantin Batygin and Mike Brown enter the picture. Brown, who famously played a role in Pluto's reclassification.
Yes, sometimes called the Pluto Killer, though he might not love that name. He and Batygin, both brilliant planetary scientists at Caltech, proposed their new hypothesis in 2016. And they weren't looking at Neptune's orbit at all. They were looking directly at that bizarre, organized clustering of the extreme Kuiper Belt objects we just talked about.
So the new evidence wasn't theoretical wobbles, it was the actual observed pattern, the alignment, the weird tilt, the stretched out orbits of those distant TNOs.
Exactly. These little icy bodies way beyond where Neptune's gravity dominates, they all seem to be dancing to the beat of some unseen conductor's baton.
But I mean, couldn't that just be selection bias? Maybe we've only found the TNOs that happen to fit this pattern, and there are loads of others scattered randomly that we just haven't spotted yet.
That was absolutely the first major criticism, and a very valid one. Observational bias is a huge challenge in astronomy. So Batygin and Brown knew they had to tackle that head on. They couldn't just say, look, they're clustered. They had to show why that clustering wasn't just an accident of discovery.
And how did they do that?
They used heavy-duty computer modeling. Specifically, something called N-body simulations. These are incredibly complex algorithms where you basically simulate the gravitational dance of many objects over millions or billions of years.
So it's like creating a virtual Kuiper Belt in the computer.
Pretty much. They started by putting a bunch of virtual TNOs out there with random orbits and let the simulation run, influenced only by the known planets.
And did they cluster?
No. In those simulations, the orbits stayed pretty random, scattered all over, just as you'd expect by chance. Then, they added a hypothetical Planet 9 into the simulation, a massive object, maybe 5 to 10 Earth masses, on a distant, inclined, elliptical orbit. And they ran the simulation again.
And what happened?
The results were striking. With Planet 9 included, the simulation did reproduce the observed clustering. The virtual TNOs ended up with aligned orbits, high eccentricities, the weird tilt, and even that crucial epsidal anti-alignment.
Wow. So this simulation basically said you need this massive object here to make the Kuiper belt look the way it actually does.
Exactly.
Yeah.
That successful reproduction, the fact that the model only matched reality with Planet 9 included, is what gave the hypothesis its scientific weight. It moved from interesting coincidence to testable prediction.
That's the validation, the smoking gun that justifies this huge ongoing search effort.
That's right. It provides a solid theoretical foundation based on matching observed reality.
Okay, so we know why scientists think it's out there, the TNO clustering and the simulations backing it up. Let's get into the profile of this unseen world. What do the models actually predict Planet 9 is like?
Well, the hypothetical specs are pretty specific, and they put it in a category of planet we don't actually have in our own solar system, at least not close in. It's theorized to be either a super-Earth or, more likely, a mini-Neptune.
Super Earth versus mini Neptune.
Yeah.
What's the difference there? And why lean towards mini Neptune?
So a super-Earth, in exoplanet terms, usually means a rocky terrestrial planet significantly bigger and more massive than Earth. Think Earth, but scaled up. A mini-Neptune, though, would be different. It would likely have a substantial core of rock and ice, maybe, but it would be surrounded by a really thick atmosphere of hydrogen and helium gas, kind of like a smaller version of Neptune or Uranus.
Okay.
Given where it likely formed and how it might have gotten out there, which we can talk about, a mini-Neptune seems a slightly better fit. But either way, composition aside, we're talking about something with a mass roughly 5 to 10 times the mass of Earth.
5 to 10 Earth masses. That's not insignificant. We're definitely not talking about another Pluto-sized object here.
No, not at all. This would be a major planet, potentially the 5th largest planet in our solar system if you count it, depending on its exact mass. A serious player.
And its defining feature, apart from its mass, is just how incredibly far away it's supposed to be.
Exactly. The orbit isn't just big, it's vast. And highly elliptical, meaning it swings much closer and much farther from the sun over its orbit. Predictions put its average distance somewhere around maybe 300 times farther from the sun than Earth is, so 300 astronomical units.
300 AU, that's what, 20 or 30 times farther out than Neptune?
Yeah, roughly in that ballpark. Which means its year, the time it takes to orbit the sun once, could be incredibly long, somewhere between 10,000 and 20,000 Earth years.
That just boggles the mind. But it raises a huge question, doesn't it? How does a planet that big, 5 to 10 times Earth's mass, end up way out there? Don't big planets usually form closer in?
That's the million-dollar question. And the leading theory about its origin is actually pretty dramatic. The dominant idea right now is that Planet 9 probably didn't form out there in the deep freeze. It likely formed much closer to the sun, maybe in the same neighborhood where Jupiter, Saturn, Uranus, and Neptune themselves formed.
So back in the early days of the solar system, when things were messy.
Exactly. You have to picture the early solar system, the protoplanetary disk. It wasn't neat and orderly like today. It was crowded, chaotic, like a gravitational mosh pit, as you said earlier.
Right.
In that environment, planets were migrating, interacting fiercely. And the theory goes that this protoplanet 9 had a close encounter with one of the real giants, probably Jupiter or maybe Saturn.
And got kicked out.
Essentially, yeah, a gravitational slingshot effect. The interaction could have given Planet 9 a huge boost in velocity, flinging it out onto this incredibly wide, distant, and inclined orbit where it ended up.
So it's like an ejected sibling, kicked out of the family home and sent to the edge of the property.
That's a pretty good analogy, actually. It would be one of the original planetary building blocks that just got unlucky in the gravitational lottery and was exiled to the outer darkness.
Wow. It wouldn't just be finding a new planet, it would rewrite our understanding of how the solar system even settled down.
It absolutely would.
Yeah.
It implies that the early solar system was even more dynamic and perhaps violent than we thought, and that even quite large planets weren't necessarily safe from being ejected. That has huge implications for how we think planets form around other stars, too.
Okay, so the stakes are high. Let's talk about the hunt itself. If it's potentially 5 or 10 times the mass of Earth, why is it so darn hard to find? Shouldn't something that big be easier to spot?
You'd think so, but the challenge is almost entirely down to that immense distance we were just talking about. See, we find objects in the outer solar system mostly by the faint sunlight they reflect back towards us, and light intensity drops off fast with distance. It follows the inverse square law.
Right, the inverse square law. Double the distance, the light spreads out over 4 times the area, so it's only 1/4 as bright.
Exactly, and that applies twice here. The sunlight reaching Planet 9 is incredibly faint because it's traveled so far. Then, The tiny amount of light that reflects off it has to travel all the way back to Earth, getting fainter again by the inverse square law.
So it's like faintness squared.
Pretty much.
Yeah.
If Planet 9 is out at, say, 300 AU or more, it is going to be unbelievably dim from our perspective. We're talking maybe magnitude 25 or fainter.
Which is incredibly faint, right? Like way beyond what you can see with backyard telescope.
Oh, way beyond. It's fainter than most asteroids, fainter than Pluto. Finding it is often compared to trying to spot a chunk of coal against black velvet from miles away. Plus, because it's so far out, its apparent motion across the sky against the background stars is incredibly slow. That makes confirming it's actually a solar system object, and not just a faint star or galaxy, really difficult.
So what are astronomers doing? What are the actual search methods being used right now? Are they just pointing the biggest telescopes they can find at patches of sky?
It's more systematic than that, but yes, it involves using some of the most powerful telescopes on Earth. They need telescopes with large mirrors to gather as much faint light as possible, but also, crucially, ones that can survey large areas of the sky efficiently. Instruments like the Subaru telescope in Hawaii, with its huge mirror and wide field of view camera, Hypersuprime Cam, are prime tools for this kind of search.
And they're looking for just a faint dot.
They're looking for a faint dot that moves. That's the key. Proper motion. They take deep images of a patch of sky, wait maybe hours, days, months, or even years, and then take another deep image of the same patch. Then they meticulously compare the images, looking for any faint point of light that has shifted its position slightly relative to the fixed background stars and galaxies.
That sounds painstaking.
It is incredibly data intensive. And because Planet 9 is predicted to move so slowly, you might need observations spanning several years just to confirm its movement and calculate a preliminary orbit.
And I read something interesting. They're not just taking new pictures, right? They're also digging through old data, like astronomical archives.
Absolutely. That's a really important part of the current search strategy. Think about all the big sky surveys that have happened over the last decade or two for other reasons, like studying distant galaxies or supernovae, projects like the Dark Energy Survey, PES, Pan-STARRS, or even older photographic plate archives might contain images where Planet 9 was accidentally captured, but maybe it was too faint or too close to a star to be noticed at the time, or its movement wasn't obvious from just one or two snapshots.
So they're essentially going back through terabytes, petabytes maybe, of old data, hoping to find that one faint moving dot that everyone missed.
Exactly. Data mining algorithms and sometimes even citizen science projects, where volunteers help scan images, are being used to sift through these massive archives. It's possible the first detection of Planet 9 might actually come from data that's been sitting on a hard drive for years.
Okay, so the scientific hunt is real, it's challenging, it's based on evidence, but now we have to pivot. We've spent all this time on the serious, evidence-based pursuit of Planet 9, but we can't ignore the elephant in the room, the huge cultural shadow cast by the other meaning of Planet X. We need to talk about Nibiru.
Right, and it's crucial we draw a really thick, clear line here. When you hear people talking about an apocalyptic Planet X, or specifically Nibiru heading towards Earth, you've left science entirely. You are squarely in the realm of pseudoscience, often tangled up with doomsday predictions and, frankly, some pretty wild alien theories. The sources we looked at are unanimous. This side of the Planet X coin has absolutely zero basis in scientific fact. It's myth and modern conspiracy, full stop.
It's a complete break from the Planet 9 hypothesis we've been discussing, which, again, is driven by observable gravitational effects on TNOs.
Totally different universes. One is physics, the other's fiction.
Okay, but the word Nibiru itself, it does come from somewhere ancient, right? It's not totally made up.
The word has ancient roots, yes.
Mm-hmm.
That's part of what gives the myth its veneer of credibility for some people. But its modern catastrophic meaning is a complete fabrication based on, well, extremely flawed interpretations of ancient texts.
So what did Nibiru actually mean originally?
In ancient Mesopotamian languages, like Akkadian and Sumerian, the word Nibiru basically meant something like a crossing point or a point of transition. Think of it like a ferry crossing or maybe a celestial marker point. Astronomically, in Babylonian texts, Nibiru was a specific celestial object they observed. It was strongly associated with their chief god, Marduk. And here's the critical part. The overwhelming consensus among actual scholars who study these texts, archaeologists, linguists, historians of astronomy, is that the astronomical Nibiru the Babylonians referred to was almost certainly the planet Jupiter.
Jupiter.
Yeah.
Regular old Jupiter. Our Jupiter.
Most likely, yes.
Yeah.
Sometimes maybe Venus or possibly a specific star used for marking time. But Jupiter is the leading candidate identified by scholars who actually read cuneiform. It fits the descriptions in the astronomical tablets.
So not some rogue 10th planet on a crazy orbit. What about that whole idea that the ancient Sumerians knew about this hidden planet that swings by Earth every few thousand years?
Pure invention. There is absolutely zero evidence in any legitimate translation of Sumerian or Babylonian texts to support the idea that they believed Nibiru was some massive, rogue planet on a long elliptical orbit that posed a threat to Earth. They were incredibly sophisticated astronomers for their time, meticulous observers, but the notion of Nibiru as a doomsday planet is a modern fiction imposed onto their writings. It's not there in the original sources.
Okay, so if the ancient meaning was basically Jupiter or crossing point, how on earth did it morph into this global internet hoax about a cataclysmic collision? Where did that story come from? We need to trace that path.
We can trace the modern Nibiru myth pretty directly back to one specific author, Zecharia Sitchin. In 1976, he published a book called The 12th Planet. In it, Sitchin put forward his own, highly unconventional translations of Sumerian cuneiform texts. He claimed these texts described Nibiru not as Jupiter, but as an undiscovered 12th planet in our solar system. He counted the sun, moon, and the planets known then. He claimed it had this incredibly long, 3,600-year orbit. And here's the kicker, that it was inhabited by an advanced alien race called the Anunnaki, who he said created humanity.
Wow, okay. And how did actual Sumerian scholars, the experts in cuneiform, react to Sitchin's work?
They overwhelmingly rejected it. His methods are widely considered pseudoscience within academia. Experts point out that Sitchin took cuneiform symbols out of context, ignored grammar, relied on etymologies that don't hold up, and basically constructed his narrative by picking and choosing interpretations that fit his preconceived theory. His translations simply don't align with the established understanding of the Sumerian language and text developed by linguists and historians over decades.
So Sitchin basically invented the idea of Nibiru as this long-orbit alien homeworld based on interpretations no real expert agrees with.
Pretty much. He laid the groundwork, but he didn't really focus on it colliding with Earth. He was more focused on the ancient astronaut angle.
So who added the doomsday part? The idea that Nibiru is coming here to wreck things.
That layer seems to have been popularized primarily by a woman named Nancy Lieder. Starting around 1995, Lieder, who created the website Zetatalk, began promoting the idea of an impending Nibiru cataclysm. She claimed she was receiving telepathic messages from extraterrestrials. She called them the Zetas, warning her and humanity that this massive rogue planet, Nibiru or Planet X, was going to pass through the inner solar system and cause catastrophic pole shifts, earthquakes, floods, basically the end of the world as we know it.
And she actually set a date for this, didn't she? I remember hearing about this years ago.
Yes, originally the date Lieder gave for the cataclysm was May 2003.
Which clearly didn't happen.
Correct. May 2003 came and went, rather uneventfully, so the prediction failed. But instead of disappearing, the narrative just shifted. The doomsday date got pushed back and eventually became strongly linked with the whole end of the Mayan calendar phenomenon, centering on December 21st, 2012.
2012, right. That connection really seemed to boost the Nibiru story, didn't it?
Massively. It allowed the Nibiru cataclysm idea to latch on to the existing 2012 hype and become this huge viral internet hoax. It spread like wildfire online, fueled by conspiracy websites, YouTube videos, forums, causing genuine anxiety and paranoia for a lot of people around the world.
To the point where NASA actually had to step in and issue official statements debunking it, right, just to calm people down.
Yes, several times. NASA and many other scientific organizations put out detailed explanations about why Nibiru wasn't real and why 2012 wasn't going to be the end of the world. It was a stark example of how easily misinformation can spread and cause real-world fear, even when it has zero basis in reality.
And of course, December 21st, 2012 also passed without incident. But the myth still persists somehow, doesn't it? People just keep pushing the date back.
Exactly. The goalposts keep moving. But the reason we can be so confident in dismissing it isn't just because the dates keep failing. It's because the entire concept is fundamentally impossible, according to basic physics and observation.
Okay, let's deliver that knockout blow. Let's break down the clear scientific reasons why a Nibiru-style cataclysm is impossible. You mentioned 3 key impossibilities.
Right, let's go through them. Impossibility number 1 is the most straightforward: lack of observation. It's simple, really. If a planet, any planet, let alone a massive one capable of causing global disaster, were actually on a trajectory to enter the inner solar system and pass close to Earth, it would be blindingly obvious. Long before it got anywhere near us, it would become one of the brightest objects in the night sky. Its reflected sunlight would make it easily visible, first through telescopes, then binoculars, then eventually even to the naked eye. It would likely outshine Venus or Mars.
And astronomers would see it coming years, maybe decades in advance.
Absolutely. It would be tracked constantly by thousands of professional and amateur astronomers worldwide, not to mention military and government sky surveillance systems. There's literally nowhere for a planet-sized object to hide if it's approaching the inner solar system. The fact that no such object has ever been observed, ever, is definitive proof it isn't there.
So the argument that it's hiding behind the sun or something is just nonsense.
Complete nonsense. Orbital mechanics don't work that way. It couldn't stay hidden. So that's impossibility one. We don't see it, therefore it's not coming. Impossibility number two, gravitational effects. This is where physics really slams the door shut. A massive object like the purported Nibiru, especially if it were on some kind of long, recurring orbit that brought it through the solar system, would exert a powerful gravitational influence. We wouldn't just detect its gravity when it got close. Its gravitational pull would subtly but measurably perturb the orbits of all the other planets, especially the inner ones like Earth and Mars, for a very long time.
Because gravity works over huge distances, right? It wouldn't just suddenly turn on when it arrived.
Exactly. Its effects would be cumulative. The orbits of the planets in our solar system are incredibly stable and well understood. We can predict their positions with amazing precision centuries into the future. That very stability is proof that no massive rogue object has come barging through the neighborhood recently, certainly not within the last million years or more. If Nibiru existed and passed through periodically, the orbits of Mars, Earth, Venus, etc., would show clear signs of disturbance. They don't.
So the very orderliness of our solar system is evidence against Nibiru.
Precisely. The source material is quite clear. The measured stability of planetary orbits provides strong evidence that no rogue, planet-sized object has passed through the inner solar system in geologically recent times. If Nibiru were real and on its way, our orbital calculations would already be going haywire. They aren't.
Okay, and the third impossibility. You mentioned orbital stability itself.
Right. This relates to the proposed orbit of Nibiru, that supposed 3,600-year cycle. For a planet to maintain such a bizarrely long yet regularly repeating orbit that intersects the inner solar system, well, first, it's incredibly unlikely dynamically. More importantly, such an orbit would be inherently unstable over long periods. Why? Because of the immense gravitational pull of Jupiter and the other giant planets. Any massive object repeatedly plunging through the inner solar system like that wouldn't stay on a stable path for long. The gravitational interactions would inevitably alter its orbit significantly over time. It would either be thrown out of the solar system entirely, captured into a different, more stable orbit, or eventually collide with the sun or another planet. It couldn't just keep making these precise 3,600-year loops indefinitely without leaving obvious gravitational fingerprints or suffering orbital disruption. The proposed Nibiru orbit defies long-term gravitational dynamics.
So no observation, no gravitational effects, and an unstable orbit. That seems pretty conclusive.
It's about as conclusive as science gets. The Nibiru myth is demonstrably false, based on fundamental principles of physics and astronomy.
Okay, so let's try and bring this all together. We've journeyed from the edge of the solar system, looking for Planet 9, down into the weeds of internet hoaxes.
Yeah, as we synthesize this whole deep dive, we really come back to that core lesson, don't we? The name Planet X stands for two completely separate phenomena. It's really a fascinating case study. You have this legitimate, cutting-edge scientific quest driven by hard evidence.
The search for Planet 9, based on those clustered TNO orbits, the math, the simulations.
Right. A search fueled by physical evidence that demands an explanation. It's based on real-world observations, rigorous calculations, testable predictions. That's science in action.
And then completely separate, you have this persistent cultural misinformation, the Nibiru myth.
Which is driven by misinterpretations, conspiracy theories, and frankly, a disregard for basic physics. It's a modern hoax, amplified by the internet, whose claims are demonstrably false.
So the true value here is understanding that distinction. The real discovery potential lies with Planet 9.
Absolutely. We're watching astronomers literally redraw the map of our solar system, pushing the boundaries of detection technology to find what could be a 5 to 10 Earth-mass mini-Neptune, orbiting hundreds of times farther out than Earth. That's the genuinely exciting frontier.
And we can and should confidently dismiss the Nibiru stuff as pure pseudoscience. The dates failed, the physics is impossible, it's just not real.
Correct. The scientific search for Planet Nine continues, and that mystery is profound enough on its own. Which maybe leaves us with a final interesting thought for you, the listener, to mull over. What does it really mean for the history of our solar system if we do find Planet Nine, and if the ejection theory is correct?
If it really did form close in and got flung out, probably by Jupiter or Saturn.
Yeah, what does that incredibly chaotic event tell us about how planetary systems form and settle down? How stable was our own system in its youth? And maybe, how rare is the kind of long-term stability that allows life like ours to eventually emerge?
It suggests our current solar system might be the survivor of a really rough and tumble early phase, a game of planetary billiards where not everyone made it to a stable pocket. Something to think about. Definitely something to think about. Thank you for joining us on this deep dive into the science, the history, and the myths surrounding Planet X.